Hello, this is Chris Houston, and this is my summary of our final report for GEO 3452. My report was on bacterial meningitis. Throughout researching this, I studied at least 6 other articles, peer-reviewed articles. The one I chose was this article here, Community-Acquired Bacterial Meningitis in Cuba. This was a cohort study taken over the course of 10 years, and I will describe the study right now. So, the breakdown of this study and this presentation is as follows. The sections are right here, all 8 sections, including introduction, references at the end, and all of the other topics that we'll go over soon. The introduction here is a basic breakdown of what bacterial meningitis is. All of this information was obtained from the CDC website, describing basically the definition of bacterial meningitis being a very serious and deadly disease. Talks about some of the symptoms. Some of the causes are listed right here. These are the main bacterial pathogens that cause bacterial meningitis. And then some diagnoses listed at the bottom here, as well as treatment. All this information can be obtained through going to this link at cdc.gov. This showcases the worldwide effect of bacterial meningitis. As you can see, the United States is not the highest affected. The areas most affected are here in Africa, sort of a main region of bacterial meningitis as determined by the WHO, the World Health Organization. If we look a little bit closer here into the Caribbean, we see some spiking of much larger rates down here. And we are going to take a look at the country of Cuba here in detail. So as the study objective goes, there are 2 main features here, the geographic study and the associated demographic study. The location of this study, it focuses on the island nation of Cuba. The geographic factors studied are the regional population density, the location of peoples and cases on the island, and the distance to healthcare professionals and healthcare facilities. As well as transportation routes. Population areas were denoted as or broken down by provinces. Other factors aside from the geographic study were analyzed: gender, societal groups such as occupation, and marital status, and other things which we'll go into in a little bit. Here is a map of the Cuban provinces. As you can see, they're broken down into the western, eastern, and central regions, but each one of these denotes a separate province in Cuba. This is the central area of Havana, which is the capital. Here is another breakdown of the population density. As you can see, it's rather well distributed with the exception of the capital area here to the west, and a little bit more populated here in the east near Guantanamo Bay. As you can also see, some of the provincial capitals here also have a much higher population density. So for the methodology, this, as I said before, is a cohort study. It included about 4,000 confirmed cases of bacterial meningitis. This was taken over the course of 10 years, and these cases were reported to the Institute Pedro Corey by the National Bacterial Meningitis Surveillance System that was created in Cuba. This is all based on the open healthcare system that they started in the 50s. These cases shown up here are per 100,000 people, and they span from January 98 to December of 2007. Now, this being a cohort study, relative risk was calculated for several features, including the transportation and proximity distance from people to healthcare facilities. But odds ratios were also calculated for some of the societal features and the case fatality rates. Here, first we have studied the delayed medical access. It was thought that, or supposed, that the distance of people from the healthcare facilities or the lengthy transportation could have negatively affected the outcome. But it was actually determined after doing a relative risk assessment that there was a poor association between the delayed consultation of a doctor or to a medical facility and death, meaning that it was not an actual factor, it was more of a confounding factor. After running odds ratio analyses, they did find positive associations with death rates, increased death rates, and certain societal factors such as occupation. We'll get to the specific societal factors further in the study. For data collection, they actually collected quite a bit of data for the cases and the information about the people participating in the study. It was very dependent on settings that had been set up early on in the 60s. This began with 1961 and mandatory reporting, which is implemented by their relatively new public health ministry. That developed in 1979 with an increased invasive meningococcal epidemic. It led to the desire for a more complete, quote, direct information system database where they could have all of these cases and study them. It further developed in 1983 where they had an automated questionnaire implemented which would report all bacterial meningitis cases. In the modern times, starting in 1998, they wanted, the country of Cuba wanted to see all causative bacteria basically put under surveillance, not just the specific ones related to bacterial meningitis. That way they could get more of a complete database picture of all of the pathogens on the island. And they have a national program for control and prevention of the neurological infectious syndrome. This organization wanted to create a national database of their own. Population results, including the population density I showed earlier, and other population societal factors were captured from a national census data database. The demographic information specifically that was captured for the purposes of this study included age, occupation, gender, residence, and admittance dates. These admittance dates were the dates and times that people either consulted with a doctor or were administered into a hospital. So, after analyzing all this information, some of the results that were determined are for morbidity. The cases for bacterial meningitis are actually on a decreasing trend from 1998 to 2007. Though many age groups are actually decreasing, there are a few that were actually leveling out or increasing. The age groups 12 to 14 as well as 45 to 49 are on just a slight increase over that 10-year span. But overall, the highest numbers of cases were in infants, which were 6 years and under, and the elderly, which were at 74 years and older. They also noticed a slightly higher incidence rate in males as opposed to females. The causes for this, not a big surprise, mostly the main three bacterial pathogens which are commonly known to cause bacterial meningitis were found in large percentages, 23.6%, which is the Streptococcus pneumoniae, which was one of the larger ones, was found, as well as all of these other two, and 6.9% for other identified bacteria. However, that only made up about 40% of the findings. There were a further 55.3% of the bacterial agents that were found were said to be unknown at the time and require further study. Spatially, they found that higher case fatality rates were in the center provinces as opposed to the east or west coast provinces. There are a high number of cases located within the highly populated areas as well, such as the capital of Havana and areas over in Guantanamo Bay, which was interesting because the overall density did not necessarily correlate exactly to the population density, so there were definitely other factors in play. The distance to the health facilities, however, was determined not to be a factor in the death rates, so if there are areas that are further away from highly populated or highly urban areas, there must be other factors besides the proximity to health facilities which are causing or cause for the higher case fatality rates. And we can see a chart here for the morbidity. This illustrates the age factor, as we can see the vastly higher incidence rates for infants at a very young age. This drops sharply once we get to 1 to 5 years of age, and drops almost its lowest in about the 30 to 34 age group here. But as we can see, it just slightly trends up towards the older you get. However, it was noted, and I'll mention this later on, that some of the age statistics for some of the more older parts of the population not quite as reliable as some of the younger and infant statistics that were gathered. We can also see that the case fatality rate here is similar, but it increases sharply after the age of 24, and it extends much higher than the incidence rates. I should note also that despite the fact that incidence levels were shown to be higher in males than females, actual case fatality rates were slightly higher in females. And these are other things that will need to be studied further within this study. Here's a breakdown of some of the causes, the bacterial agents that were shown. As we can see, the unknown agents here, which are not broken down any further, certainly require more investigation to determine what these are, as opposed to the other known agents for causing bacterial meningitis. Spatially, this is a map indicating the higher case fatality rates, which were, as you can see, in the central provinces here. Interesting to note that it is actually quite different from the population density map earlier. If these were just based on population and population density, we might see that areas over here and over to the east here may be the highest case fatality, but in effect it was actually the central regions. And it suggested in the study that this could be due to low socioeconomic status, potentially impoverished regions here, as well as in the capital and Guantanamo, and not necessarily related to the location or number of health facilities or doctors. So in conclusion, some of the noteworthy findings in this study: timely consultation, transportation routes were not really deemed a factor, poor association of risk. However, fast recognition of the symptoms as well as good care-seeking behavior did in fact reduce fatality over that 10-year period. Also, good reporting, Cuba's free health service, which was implemented in 1959, as well as regular reported cases and disease databases. They are directly linked to the decreasing incidence rates over 10 years. This could also be compared to surrounding nations. Cuba's healthcare infrastructure development and high reporting rates and data collection attributed to high vaccination coverage as well. The social factors, or societal factors that were found, showed positive associations with the case fatality rates. Those who are categorized as a housewife or pensioned, unemployed persons, as well as imprisoned, showed a much higher case fatality rate than those who were not. Other social interactions, such as population exposure, are suggested as a possible factor. This may also determine the differences between male and female incidence rates. And vaccinations, this of course plays a major role. The meningococcal bacterial vaccination, which is implemented at 3 months and 5 months old, as well as the HIV vaccine, which is administered at 2, 4, and 6 month old, with another booster shot at 18 months old. Finally, the limitations of this study. Overall, they did a rather good job of trying to touch on all the bases. However, there were a few issues that could be a limiting factor for its accuracy, and something to address in further studies. Using the human ecology triangle here, I can break this down into a population. Definitely more information needs to be studied, which can explain increased incidence in males as compared to females, and the higher case fatality rate in females as opposed to males. There may be actual genetic factors, if not societal factors or social factors. They also need better age statistics and age recording for some of the more elderly groups in the population. For the habitat, there are low socioeconomic regions which appear to be at greater risk, according to this study, and they have highly virulent bacterial meningitis agents. So more data needs to be determined to see exactly what about these areas are causing the highly virulent agents to thrive. Also, cases increased in the months of January, September, and March. This isn't actually gone over in the study all that much, but I think this could warrant further study as well. This may also have a geographic element to it as well. Unknown local agents, probably the biggest thing that needs to be studied, and to determine what the overall pathogens are that are the largest cause for bacterial meningitis here in Cuba. And finally, behavioral. These societal factors, such as the population exposure and how the population interact, both male, female, old, and young. This needs to be further defined. And the employment. It was noted that housewives and those that are unemployed, as well as those that are incarcerated, are much more likely to die from bacterial meningitis than those who are not. And I think this needs to be broken down and further investigated as well to determine what other possible social aspects may be the cause. Okay, here are the works that I used. This includes the 6 peer-reviewed studies that I read. The main one here that I went over is right here, and a few other ones too, such as the World Health Organization and the Center for Disease Control, cdc.gov. Thank you very much. If you have any questions, please email me at khouston@ufl.edu, and thank you very much.